Inferential statistics pertain to taking a small sample of a population and then using that sample to estimate the characteristics of the larger population from which the sample has been drawn. One specific statistical test you can use to make inferences about a population is chi-squared. Chi-square allows us to determine if there is a relationship between two categorical variables. We can do this by calculating how closely the values of an observed sample of data match the values we would have expected if there were no relationship between the variables. As you might infer from the fact that this test is used on categorical data, chi-square is a non-parametric test. Non-parametric tests make fewer assumptions about the data than do parametric tests. We do not need to assume, for example, that the data is normally distributed or that variances are homogeneous. However, this trade-off also means that non-parametric tests are much less powerful than parametric tests. Chi-square is used when you have nominal independent variables, but only frequencies as your data. For example, suppose that our organization, we think that our newest employees, who seem the most enthusiastic and eager, are taking the most advantage of our informational weekly colloquia, and our longer tenure employees are more likely to skip out, having attended for many years. We can state our question in the form of a research hypothesis like, the frequency of colloquium attendance differs among new, mid-tenure, and long-tenure employees. We can define our newer employees as having been at the organization 2 years or less, our mid-tenure employees as having been at the organization 3 to 9 years, and our long-tenure employees as having been at the organization 10 years or more. Over the span of 6 months, we could count how many times employees attended the colloquia, never, sometimes, or always. Then we could create a contingency table of our observed frequencies. Across our 50 newer employees, 11 never attended, 17 sometimes attended, and 22 always attended. Across our 50 mid-tenure employees, 17 never attended, 19 sometimes attended, and 14 always attended. And across our 50 long-term employees, 20 never attended, 17 sometimes attended, and 13 always attended. On the face of it, it certainly seems like there are many more long-term employees who never attend the colloquia as compared to newer employees, 20 versus 11, almost twice as many. But is this significant? In order to determine if the pattern of attendance represents a statistically significant difference between groups of employees, we can conduct a chi-square test. It requires either manual or computer calculation of the value of the test statistic chi-square, which is in turn used to determine the probability that the null hypothesis of no difference is true. Usually, if the probability that the null hypothesis is true is less than 5%, or p less than 0.05, then we can reject the null hypothesis and accept our alternative hypothesis that the frequencies, and therefore the groups, are different. Interestingly, when we calculate chi-square for this particular data set, the p-value of chi-square is 0.22. This is much greater than 0.05, and therefore we cannot reject the null hypothesis. So even though the numbers may initially appear systematically different, we cannot reject the idea that this distribution of frequencies is not different than we would expect from a distribution created by random chance. There are a few important things to keep in mind with respect to chi-square. First, for chi-square to be meaningful, each data point can appear in only one cell. Therefore, you cannot use chi-square in a repeated measures design. For example, if your data comes from testing a group and then retesting it. Second, all calculated expected frequencies in each cell of the contingency table should be greater than 5. Overall, the chi-square test is a commonly used inferential statistic that you'll need to know in order to conduct basic research. You will also see it frequently in the scholarly literature. It's important to understand why and how it is used so you can both conduct your own research and evaluate the literature appropriately.